Welcome students of Thakur Vidya Mandir High School and Junior College. Today we will study the first chapter of physics, rotational dynamics. The first chapter of physics, rotational dynamics, deals with two types of motion, uniform circular motion and rotational motion. Uniform circular motion is dependent basically on two types of forces acting on it, namely the centripetal force and the centrifugal force. Let us define what is centripetal force. It is a force which is acting vertically inwards towards the center of the circular motion. It is evident from the diagram which is shown here, the inward force acting towards the center of the circle. Define centrifugal force. Centrifugal force is a force which is acting away from the center of the uniform circular motion. The diagram clearly represents the outward force going away from the center of the circle. Let us go on for the example which shows us the applications of uniform circular motion. We are going to study the three examples, namely vehicle which is moving along a horizontal circular track, a vehicle which is moving inside the well of death, a vehicle which is moving on a banked road. So students, let us derive the relation which is showing us a formula representing the maximum speed by a vehicle along a horizontal circular track. You can see from the diagram which clearly states us two arrows, the one which is pointing vertically upwards and the second one which is pointing vertically downwards. The upward arrow represents the static force of friction, that is of the vehicle on the surface of the road. The second arrow, which is pointing vertically downwards, is the weight of the vehicle represented by mg. You could as well see a small horizontal line which is representing a small r. This is the distance of the vehicle from the center of the surface of the road on which it is swiping a horizontal circular track. Let us move further and explore the frame of reference attached to the vehicle. Firstly, the centrifugal force balances the weight of the vehicle. Therefore, the weight of the vehicle is given as mg equals to n. And the force of static friction exhibited by the vehicle is given by the formula mass multiplied by the radius multiplied by angular velocity, that is omega. F is equal to mr omega square, which in turn could be also written as centrifugal force which is acting is mv square upon r. If I take the ratio of both the values, that is the static friction divided by the normal which is acting on the vehicle of the body, it could be given by a ratio of mr omega square divided by the weight of the vehicle, where your m gets cancelled both in the numerator as well as denominator, giving you a final formula of v square upon rg. The speed v increases if we increase the force of the static friction. Therefore, the upper limit, that is the force of static friction, is represented by a value which is called as mu s. Mu s is nothing but the coefficient of the static friction. Let us proceed further. At the maximum possible value, the speed of the vehicle could be written by the ratio of the static friction divided by capital N. Finally, what we get is nothing but the speed of the vehicle which is moving along a horizontal circular track represented by v square equals mu s rg. Therefore, v max, that is the maximum speed of the vehicle, is given by square root of mu s rg. Let's proceed further to the second example of the vehicle moving in a well of death. You can see a cylindrical diagram over here. This is nothing but the well of death. The horizontal walls, which are in the form of a cylinder, is representing two opposite forces acting on it. The upward force is again the static force of friction, and the downward force is the weight of the motorcyclist which is moving in the well of death. The forces which are acting on the vehicle are assumed to be a normal reaction acting horizontally towards the center. So you could see is capital N represented by a horizontal line with a perpendicular line representing the static friction and the weight which is acting vertically downwards. If I move on to the derivation of the formula, again I will take on the ratio of the normal, which is equal to mr omega square, divided by the static force of friction, which is equal to the weight of the vehicle. The static friction, when compared with the static force of the friction multiplied by the normal which is acting on the vehicle, it is comparatively lesser. The static force of friction is equivalent to the weight of the vehicle. Therefore, mg is less or equal to the static friction multiplied by centrifugal force acting on it. That is, mg is lesser or equal to mu s multiplied by mv square upon r. Therefore, v square is greater or equal to Rg divided by coefficient of static friction. We finally come on to the formula where the minimum velocity of the motorcyclist to drive in the well of death is given by V minimum is equal to square root of Rg upon mu s. Let us proceed on to the third and the last example of today's topic, that is the circular motion on horizontal curved road. Vehicle on a banked road. What do you understand by a banked road? Students, in real life, the surfaces of the curved road are tilted with the horizontal with some angle, and that angle is called as theta or the banking angle. If you see the diagram which is stated out here, it is very clear. The diagram is showing a vehicle which is on a tilted line, and there are two perpendicular lines. The one which is showing n sine theta followed by n cos theta. The force that is acting vertically downwards is mg. You could see a smaller angle which is represented by a horizontal road to the tilted surface is represented by theta. Theta is nothing but the angle of banking. Considering the vehicle to be a point and ignoring the friction, the non-conservative forces like air friction, the two forces which we consider to act on the vehicle are: firstly, the weight mg acting vertically downwards. Secondly, the normal reaction N acting vertically upwards. It means that the vehicle has to be balanced by the two resolution of the forces, that is the normal reaction along the vertical component n cos theta, balanced by the weight mg. Therefore, the magnitude of the vehicle or the speed of the vehicle can be given by a comparative values of n cos theta is equal to weight mg of the vehicle, and n sine theta is equal to mr omega square, where omega is angular velocity of the vehicle exhibiting a circular motion. Therefore, we come on to the derivation of the angle of banking, where tan theta is the ratio of n sin theta to n cos theta. The normal n gets cancelled in both numerator and denominator, and the value which we obtained is v square upon rg. Let us quickly take a review of the speeds exhibited. The most safe speed is given by Vs, which is root Rg tan theta. Let us proceed on to the banking angle, which is shown in the second box out here. While designing a road, this expression helps us in knowing the angle of banking. Theta is given as tan inverse multiplied by V square upon Rg. By knowing the speed of the vehicle, we can insert the value in V square, dividing by the value of the radius and the gravitational force which is acting on the vehicle. Let us proceed further to the speed limits. Speed limits are given with a minimum speed of the vehicle with V1 minimum and V2 maximum. Therefore, the formula represents V minimum is square root of Rg tan theta minus mu s divided by 1 plus mu s tan theta. This is when your mu s is greater as compared to tan theta and the minimum velocity of the vehicle becomes equal to 0. If I move on to the greater angles where the roads are banked, V2, that is the maximum speed of the vehicle, is given by a formula root Rg tan theta plus mu s divided by 1 minus mu s tan theta. These formulas we have studied in standard 11th. If I give the condition that your static coefficient of static friction is equal to cos theta, the value of the V max is equal to infinity. Then the coefficient of static friction becomes equal to 1. So students, these were the various examples of the motion of the vehicle, showing us the applications of uniform circular motion. I hope you all understood the topic thoroughly. If there is any doubt, please move on to the links which is mentioned towards the end of this presentation. Both the links would actually help you to understand what is given in the state board textbooks of standard 12th. The various assignment questions which are mentioned out here, go through the questions, try to understand the topic and make a notes of your own. Thank you.